Okay, class, in this video I'm going to show you how to use or how to find logs and what the definition of a log is. So let's go ahead and get started with the definition. Before we start, actually, I'd like you to keep in mind something right here. You guys know that, say for example, 2 to the third power is equal to 2 times 2 times 2, which is equal to 8. Just keep that in mind. For the definition of a log, we have the following: log base a of x is equal to y. Excuse me. This is read. We read this like this. We read it as the log base a of x is y. That's how we read it, okay? But the definition goes as follows. This is true, this equation here, the log base a of x is y, if and only if a, look at this, a to the power of y is equal to x. Okay, so definition, log base a of x is equal to y if and only if a to the power of y is equal to x. Okay, so I'm going to go ahead and I meant to highlight this like this, or not highlight it, but box it. So this is a definition of a log. Let's take a look at an example here. Example. So we know that the log base 2 of 8 is equal to 3, and the reason why we know that is because 2 to the third power is equal to 8. Another example, if we call this example A, example B would be something like, what is the log base, say, 3 of 20? Let's make it 81. So the log base 3 of 81, the way we answer the right side of that equation is, think about 3 raised to what power? 3 raised to what power is 81. And so we know that 3 times 3 times 3 times 3, 4 times 3 to the 4th equals 81. So that must be true then. 3 to the 4th equals 81. Here's another one. The log base 5 of 25. To answer this question right here, we have to ask the question, 5 raised to what power? Or how many times do we have to multiply 5 by itself to get 25? And the answer is 2. Again, because 5 to the second is 25. Okay, so keep this definition in mind, and then we're going to do examples like the ones that you would normally see on an assignment for Math 3 or Algebra class. So here's an example. Let's call this example number 1. Can we write the expression in exponential form? So we're going to write this equations in exponential form. So say for example, the log base 4 of 4 equals 1. The log base, say, 5, 1 over 5 equals -1. The log base 1/2 of 4 is -2. And just one more. The log base, say, 12 of 1 is 0. Okay, so we're gonna switch this exponential logarithmic equations into exponential form by doing the following. We're gonna rewrite this as exponents. So we know that in this case 4 to the first power is equal to 4. So that's how we write this in exponential form. Okay, how do you write the next one in exponential form? It will be 5 to the negative 1 equals 1/5, and so on and so on. We're not evaluating anything, we're just rewriting it. They give it to us in log form, we need to write in exponential form. So 1/2 to the power of negative 2 equals 4. Okay, also have 12 to the power of 0 equals 1. Okay, so as part of another example, we could do exactly the reverse process of that, which would be, let's call this example 2, to write in logarithmic form. So we use log for short for logarithmic, and so here we go. How do you write 2 to the negative? Let's just do to the fifth power equals 32. How do we write that in log form? And how do we write, say, 10 to the second power equals 100? And finally, how do you write 1/5 to the negative 2 equals 25? So now we're going to switch this into logs. And how do we switch that to log? Well, we know that the base here is 2, so the 2 goes there. And then we know that when we raise it to the power of 5, which goes on the other side, the answer is 32. And we could check it by using the arrows backwards the way I did it before. 2 to the fifth power equals 32. That's exactly what the statement before says. So the next one would be then the base is 10. 10 to the second power is 100. And so here we go. Again, you can check with the arrows. And the next one would be the log of 1/5 raised to the negative 2 is 25. And so here you go. Okay, so the other type of problems, other type of exercises that you might be asked to do in a Math 3 or algebra course is to evaluate the log. And so say they ask you to evaluate what is the log base 3 of 27. What is log base 2 of 64? What is the log base 1/4 of 4? What is the log base 5 of 1? That's supposed to be D, and then E. What is the log base, say, 10 of 0.01? All right, so what we have to do is think about, going back to part A, how many times do we have to multiply 3 to get by itself to get 27? So we know that 3 times 3 times 3 makes 27, so the answer here is 3. 3 to what power makes 27? That's how we answer this question. And the next one is 2 multiplied by itself how many times will give us 64? Well, I know that 2, 4, 8, 16, 32, and 64 are powers of 2. So how many times do I have to multiply 2 by itself to get 64? Looks like it's 2 to the power of 1, 2 to the power of 2, to the power of 3, to the power of 4, to the power of 5, to the power of 6. So this should be a 6. Okay. So again, this is 2 to the power of, like that. Anyway, the next one, because we know that we're going from a fraction to a whole number, then we know that the answer is going to be negative 2. Take it back, negative 1. Because when you take 1/4 and you raise it to a negative exponent, you're going to get the reciprocal of 1/4, which is 4. The next one makes kind of sense because we know that any number other than 0 raised to the 0 power is always equal to 1. So the answer should be 0. 5 to the 0 is 1. The next one is kind of hard to see the way it is, so I think it helps if you rewrite this as the log base 10. 0.01 is the same thing as 1 over 100. Once again, because we know we're going from a whole number to a fraction, this is going to be negative. It's going to be a negative answer. And then 10 raised to the second power makes 100. And so that's what the answer is. Again, this is true because 10 to the negative 2 is 1 over 100, which, by the way, is equal to 0.01. Okay, so now that we have now that you understand what the definition of a log is, how to write between exponential and log forms, and how to evaluate logs, then you should know how to. We're gonna move into what we call basic special logs. We have 2 special logs in mathematics, but before that, I'd like to introduce you guys to what we call the natural base. The natural base is a number, and that number is about 2.7188281, something like that. But mathematicians decided, because it's a number that just keeps going and it shows up a lot in nature, that's why it's called the natural base. They give it a special name and they call it the number e. Just like the number pi, if you remember, we had a number pi, and that pi was about 3.14. Well, the natural base is 2.718289, and it keeps going, of course, like pi does, but we're going to round it to approximately 2.72. Okay, so just keep that in mind, that the number e is a special number. We call it the natural base. And so with that in mind, we have 2 special logs now. So keep that in mind, that right there was a definition. What is e? Well, we have 2 special logs. One of them is called the common log, and the other one is called the natural log. Common log is basically just a special log. We just call it a log with base 10. Whenever we have a base 10, we use the common log. And this is basically what it means. If you just write the log of x, that means that we don't write the base here, but we know that the base here is 10. So this is exactly the same thing as writing this. But again, we don't write the 10. We just know it's there. It's like a short way of writing that special log. So as an example for this, I could tell you the log 100 is 2. Now, why is it 2? Because we know there's a 10 here, and 10 to the second power makes 100. Okay, so just keep that in mind. The natural log, on the other hand, is also a log, obviously. But this time the base is a common base, which is e. Remember, again, e is a number that is approximately 2.72. But here, when we write the natural log, ln stands for natural log, we know then that this is a equal to the log base e of x. But we would never see it written this way. We're always going to write it this way. Okay, as an example, we know that the natural log of e then is 1. And the reason why that is, again, is because e, that the invisible e that is there raised to the power 1 gives us e. Okay, so keep that in mind. We have two special logs, the common log and the natural log. Now, if we need to evaluate or approximate, I believe this is example 3. Let's go ahead and approximate the value of the log. We're going to round to 3 decimals, okay? So let's see, what is the log base 2 of 80? What is the log base 1/2? Well, let me make it easy for myself. What is the log base, say, 5 of 33? And what is the log of, say, I don't know, 340? Also, we're going to go ahead and investigate what the natural log of, say, 12 is, approximately, what the natural log of 27 is, and let's take one more. What about the log of, or the natural log of 1? Just to see what we get. Okay, so what we do here is we need to get a calculator because we don't know exactly 2 raised to what power makes 80. Well, it's going to be a decimal. It's going to be an approximation because it's not an exact. 80 is not a power of 2. So what we do in that case is we go to decimals, and on decimals, if we just start graphing here, we go back and let me remember what my first log base 2 of 80. You know what? I'm going to take this back because I still have to explain to you how to enter these special logs on the calculator. So let's go ahead and evaluate it the way it is. So just a log of 80. We go here and we just type in log 80. And you notice how we get an approximation, which is about 1.903. So we go here and we get the answer is about 1. I forgot what I saw. 903. And just like that, we could evaluate all the other ones. So the log of 33, we just go back to decimals and you just type in log of 33. Something went wrong. Just type in log of 33, and we see an approximation which is 1.519. You round it up to 3 decimals. 1.519. 1.519, and we can just keep going like this. Let's go ahead and try the natural log. Let's see what the natural log does. So just type in ln, and I forgot my numbers again. Sorry about that. So natural log of 12. And you can see that you get 2.485 if you round it up. 2.485 right here, 2.485. And I'm gonna stop right here because you've seen enough. You could evaluate this one right here on your own, that one and that one, and just type them in the decimals, and it'll give you an approximation. Similarly, if you have a scientific calculator, you can just type that in and get an answer. Okay, I'm gonna stop right there with this video, so you should know. By the goal of this video was to show you what a log is. So here's the definition. Some examples. Here's some examples on how to switch back and forth between log and exponential form. How to evaluate some of the logs and what the special logs are. Okay, see you next time.